All right, let's dive in. Today, we're going to pull back the curtain on a tool that's completely changed the game for handling massive amounts of data. We're talking about Google BigQuery. If you've ever wondered how some companies can just sift through billions of records in a blink of an eye, well, you're in the right place.
So, let me paint a picture for you. Imagine you're standing in a massive library, like think the Library of Congress, and your job is to find one single sentence hidden in one of those millions of books. That's the kind of scale we're dealing with here. So how on earth do you find that needle in a haystack? And not in a lifetime, but like right now, in seconds. Well, this massive challenge actually has a name. It's called the petabyte problem. And just so we're on the same page, a petabyte is a million gigabytes. It's a staggering amount of information. Trying to analyze that much data with old school tools, it's kind of like trying to drain the Pacific Ocean with a teacup. It's just not going to work. The tools just weren't built for that job.
Okay, so that brings us to our first big topic, the petabyte problem. And really, it's all about what happens when our traditional data tools just can't keep up. They hit a wall. So let's really break down the difference between the old way of doing things and what we desperately need today.
So on one side, you've got the old world, the traditional data warehouses. Think slow, super complex, and you needed whole teams of people just to babysit the servers. But on the other side, you have what we actually need now, right? We need speed, we need things to scale up instantly, and this is a big one. It needs to be easy enough for everyone to use, not just the hardcore engineers. This huge gap, well, that's exactly where BigQuery comes in.
So the big question is, how do you solve a problem that huge? Well, enter Google BigQuery. Let's dig into what this thing actually is and what makes this whole serverless idea so incredibly powerful.
Okay, let's just break this definition down for a second because honestly, every single word here is important. When we say fully managed, that means Google takes care of all the messy, complicated stuff in the background. Serverless, that's the magic word. It means you never have to worry about servers, ever. And highly scalable just means it can grow to handle basically any amount of data you throw at it. And the best part, you do all this with simple SQL queries. But really, if there's one thing to take away, it's that word serverless. This is the absolute game changer. It means you load up your data and you start asking questions. That's it. Behind the scenes, BigQuery is scrambling, automatically finding and firing up maybe thousands of machines to get you an answer in seconds. You get to focus on finding insights, not managing a bunch of hardware.
But how? How does it actually do that? It seriously feels like magic, right? But it's not. It's just some incredibly clever engineering. So let's pop the hood and take a look inside the magic box to see the architecture that makes all this speed possible. You can really boil it down to four main pillars. First, we've already touched on the serverless model. Second, and this is huge, is the separation of storage and compute. What that means is your data can grow independently from your processing power. You don't have to pay for one just because the other gets bigger. It's brilliant. Third is a super smart way of storing data called columnar storage. We'll get to that in a sec. And fourth is the Dremel engine. The best way to think about Dremel is like the conductor of a massive orchestra, telling thousands of machines to all play their part on your one query, all at once, to give you an answer, boom, in seconds.
Okay, so to really get why BigQuery is so ridiculously fast, we have to talk about that third pillar, how it stores the data. See, a normal database stores info in rows, just like a spreadsheet. So if you want to find the average of just one column, let's say column A, the database has to read the entire spreadsheet, every single row. It's so inefficient. BigQuery flips that on its head. It stores data by column. So if you want to analyze column A, guess what? It only reads column A. That's it. This means it's reading way, way less data off the disk, and that's a massive reason why it's a speed demon for analytics.
Now, all this incredible speed, it isn't just a cool party trick for engineers. It's the key that unlocks a whole new level of what we can do with data. And that takes us from just running SQL queries all the way to doing real AI. This is where we see how BigQuery is actually democratizing machine learning for, well, pretty much everyone. And look, this idea, it's nothing short of a revolution in the world of data science. For decades, if you wanted to do machine learning, you basically had to be a PhD or a super specialized engineer. It was this exclusive club. BigQuery just blows the doors off that club. It says, hey, you know SQL, the standard language of data? Well, now you can build and run complex AI models, just like that. And just look at the kind of stuff you can build.
We're talking about everything from forecasting future sales to creating a recommendation engine like Netflix has. And it's all done with a simple command like create model. But here's the really critical part. You never have to move your data. It stays right there in the warehouse, which makes the whole process insanely simpler and faster.
Okay, so what does all this mean in the real world, for day-to-day use? In our last section, let's get down to the practical stuff, how you actually pay for this, how you can use it smartly, and where it's really making a difference out there.
Right, so BigQuery basically gives you two ways to pay. The first is on demand. This is perfect if you're just starting out or your workload is all over the place. You literally just pay for the amount of data your queries scan. Simple. But as you get bigger and your usage gets more predictable, you can switch over to a flat rate model. That gives you a nice, predictable bill every month. That flexibility is it's key.
And the great thing is, you have a ton of control over your costs. Here are 3 tips that are absolutely essential. First, partition your tables. That's a fancy way of telling BigQuery, hey, only look at data from last week, which saves a ton of scanning. Second, never, ever use select star. This goes right back to that columnar idea. Just tell it the exact columns you need. And the best one of all? BigQuery caches your results. So if you run the exact same query again within 24 hours, it's free and instant. How cool is that?
So where is all this power actually being put to work? Well, pretty much everywhere you can imagine. We see it in everyday business intelligence, dashboards and reports, but it's also analyzing these enormous streams of data coming from Internet of Things devices, and it's even powering cutting-edge scientific research in places like genomics. It's just an incredibly flexible, powerful tool.
Okay, let's wrap this up. What are the key things to remember? 1. Serverless power. It lets you focus on insights, not infrastructure. 2. The architectural genius. That combo of separating storage and compute with columnar storage is what gives you that incredible speed. 3. SQL is king. The language we all know and love isn't just for pulling data anymore, it's for building AI models. And 4. This whole thing democratizes analytics. It puts the power to answer huge questions directly into the hands of everyone, not just the tech gurus.
And that kind of brings us to a final really big thought. For so long, our ability to answer the biggest questions was held back by our technology, by our tools. But now the tool is basically limitless. The only thing holding us back is the quality of the questions we ask. So when analyzing this much data becomes this easy, what questions are we finally going to be able to answer?